Okay, Assalamualaikum and very good morning to all of you. So today we will learn about metal metric composite MMC. This is the first for the introduction for MMC. So topic outcomes. At the end of this topic, you should be able to identify the metric in MMC, determine the reinforcement in MMC, and understand the interface in MMC. So for the today's topic, it will be cover three things. First, metal metric composite or MMC is a composite material in which one constituent is a metal or alloy forming at least one per, uh, percolating network known as the metric. The other constituent is embedded in this metal metric and usually serve as reinforcement. So, as we know, composite metal metric composite metal acts as a metric. So the primary is your metal. How MMC is different from other composites? The metric phase of an MMC is either a pure or alloy metal. So for this MMC, it can be single metal or alloy metal. Alloy metal means it's combined two or three metals together. So MMC have higher ductility and toughness than CMC, ceramic metric composite. Reinforcement in MMC is to increase strength and modulus. MMC has a temperature capability generally higher than polymers and PMC, but less than ceramic and CMC. So this is the temperature capability. So as we know, the metal temperature is much higher compared to the polymer, but less than ceramic CMC. So low to moderately reinforced MMC can be fabricated by common metal processing method. MMC have higher density than PMC and CMCS. What is the difference between composite materials and alloys? Composite, a material system composed of a mixture of combination of two or more constituents that differ in form or material composition and are essentially insoluble in each other. Maksudnya sama juga yang macam saya terangkan apa itu composite. Dia adalah single material ataupun two or more material yang sama digabungkan dengan material yang berbeza untuk menghasilkan composite. Maksudnya metal dia gabung dengan either polymer ataupun ceramic, dia akan gabung dan dia akan membentuk composite. Manakala metal alloy, a metal product containing two or more elements as a solid solution, as an intermetallic compound or as a mixture of metallic phase. Maksudnya metal alloy ni adalah gabungan daripada metal dengan metal sendiri. So it will create metal alloy. Classification of MMC, composite with metal phase. It can divided into four: dispersion hardened and particle composite, layer composite, which is laminate, fiber composite, and infiltration composite. Metal metric. The metric typically is tougher than the other phase, usually known as the reinforcement. Maksudnya metric ni dia tough daripada reinforcement. Sebabnya dia nak kawal. Macam yang saya beritahu apa itu fungsi metrik, apa itu fungsi reinforcement dalam first lecture hari tu. So in the metal metric, it support and binds the reinforcement together, provide environmental protection for the reinforcement, transmit load from one piece of reinforcement to the other, usually by shear, and carries the shear stress of the composite. Consideration on metric selection. This one is for MMC. Ni kita dah tumpu kepada metal itu sendiri, bukannya overall untuk composite. So consideration on metal metric selection is reinforcement or metric reaction either during processing or in service, thermal stress due to the mismatch of thermal expansion, influence of metric fatigue behavior on the cyclic response of the composite, The behavior of MMC under cyclic loading condition, the use of MMC at elevated temperature, the difference in melting temperatures between the metric and the reinforcement. A large melting temperature difference may result in metric creep while the reinforcement remain elastic. So yang ni yang kamu kena tengok dalam pemilihan metrik. First kita tengok reinforcement ataupun dia punya apa yang akan menggabung. Bila kamu gabungkan metrik dengan reinforcement, dia punya reaction. Sama ada semasa processing ataupun selepas proses. In service, maksudnya selepas dia jadi produk. Thermal stress, maksudnya bila dalam lecture tu saya ada terangkan apa itu CTE, thermal expansion. So dia nak tengok adakah metrik dengan reinforcement kamu tu dia ada perbezaan yang ketara. So the next one is the influence of metric fatigue behavior on the cyclic response. Ini dia nak tengok metal kamu sendiri, pemilihan metal kamu sendiri, adakah dia akan bagi fatigue behavior bila kamu gunakan cyclic response, maksudnya daya yang berulang-ulang ke atas metal itu sendiri. So the behavior of MMC under cyclic loading condition sama juga yang ni. Dia tengok cyclic, maksudnya dia berulang-ulang. So the use of MMC at elevated temperature, maksudnya kamu nak go for what type of application. Sometimes metal tu sendiri dia tak boleh go for higher temperature. So setiap metal dia mempunyai setiap berbeza dia punya takat lebur dan juga melting temperature dia. So for example, aluminium, lithium alloy, magnesium, copper, titanium and super alloy. So ni antara contoh-contoh metrik yang kamu boleh tengok. So many MMC application involve consideration other than strength alone. Example, electrical contact. So there are corresponding requirement for many types of metric material. So kalau kamu tengok, ini adalah pure metal, which mean single metal. Dia soft, weak, low strength with high ductility, high in electrical and thermal conductivity, easy plastic deformation. Plastic deformation. Yang ni, as a material engineer, you must know what is elastic deformation, what is plastic deformation dan seterusnya. Apa itu yang dikatakan dengan ductility? Apa itu yang dikatakan dengan fragile? So, you as material engineer, you must know what is ductility and so on. So, for metal alloy, example, aluminium alloy, magnesium alloy, titanium alloy, nickel alloy, etc. So, the metal alloy, it has low density, high melting point, high strength at elevated temperature. So, this is the metal alloy. So, this is the difference between pure metal and metal alloy. So, high melting temperature material, this is the example for high melting temperature material, molybdenum, niobium or tungsten. Ordinary melting temperature materials, iron, nickel, copper, titanium. But for low melting temperature materials, aluminium, magnesium. So this is the example of material that you can use in metal metric composite. So if you want go to for higher application, higher temperature, you can use this one, high melting temperature. So you must know before you produce a product or you want to make a composite, you must know each material, the temperature of each materials. So reinforcement, role of reinforcement. So in the first lecture, I also show you what is reinforcement and the uses of reinforcement. So this is some kind of refreshment to increase the strength, stiffness, modulus, temperature capability, and to reduce the CTE, thermal expansion coefficient. So this is the role of reinforcement. So demand of reinforcement in MMC, it has low density mechanical capability, a thermal expansion coefficient which is low but adapted to the metric. Ini yang saya beritahu tadi. Dia kena tengok apa itu dia ada, adakah dia terlalu berbeza dengan metal metric sendiri dengan dia punya reinforcement. So the third one is chemical capability, thermal stability, high young modulus, high compression and tensile strength, good processability, economic efficiency. So this is the reinforcement. Common reinforcement material for MMC, this is the common material. Bukannya tak ada guna benda lain, tapi ini kebanyakan digunakan dalam MMC, oxide, carbide, nitride, etc. So this is the reinforcement. Contoh dia punya properties of reinforcement: sapphire, SiC particle and alumina particles. So this is the properties. The reinforcement, as you can see, this is your metric: aluminium alloy, aluminium lithium alloy, steel, titanium alloy. So bila dia digabungkan dengan kamu punya composite ataupun reinforcement, dia akan mostly dia akan naikkan lagi dia punya yang modulus, kamu punya strength. So yang ni kamu tengok, ini adalah single ataupun kamu punya metric. Ini epoxy resin, dia punya yang modulus dia terlalu rendah, ikut dia rapat ke sebelah kiri. So this is the type of reinforcement. Discontinuous reinforced MMC to strengthen and stiffen through prevention of metric deformation by mechanical restraint. Metric is the major load bearing constituent. So continuous, ada hari tu saya dah terang apa itu type of reinforcement, either particles, either fiber, long fiber, short fiber, discontinuous, continuous. So this one is for continuous, discontinuous reinforced. Ini dia punya apa yang kamu dapat. So continuous reinforced MMC, the reinforcement is the principal load bearing constituent. Metric serves to hold the reinforcing fiber together and transfer as well as distribute the load. So ini if you use continuous reinforced MMC such as fiberglass and so on. Yang ni boleh tengok balik dalam first lecture saya dulu, apa itu discontinuous, continuous reinforced. So this is the type of reinforcement that we use. Monofilament, this is the reinforcement. Sorry. So this is your reinforcement. This is the short fiber. This is monofilament, which is long fiber. This is the particles inside. Okay. So for the reinforcement, alumina melting point is 2045 degrees C. Strength retention is about 1370 degrees C. SiC silicon carbide melting point is about 2830 degrees C. Strength retention is 650 degrees C to 1000 degrees C. Carbon, boron, titanium, diboride, alumina to silica, tungsten, carbon or graphite. This is type of reinforcement that you have that you can be used in the MMC. So the composite strength of particulate reinforced composite depends on the, please take note so the composite strength of particulate reinforced composite yang ni. Particulate reinforced composite, they depend on first diameter of the particles, the interparticle spacing, which is the interparticle spacing, volume fraction of the reinforcement, and also size and shape of the particles. So kamu guna different size, different volume fraction of particulate, dia akan memberi efek yang berbeza kepada kamu punya komposit. So, next kita akan masuk kepada interface antaramuka ataupun interface antara fasa. There is always an interface between constituent phase in a composite material. Ini pun saya dah terangkan dalam lecture 2, interface dan juga interfasa. For the composite to operate effectively, the phase must bond where they join at the interface. Ada saya tunjuk kalau apa yang terjadi kalau antara muka kamu kuat dan juga antara muka kamu rendah. Antara muka ni refresh balik ini kamu punya metrik dan ini kamu punya reinforcement. Ini yang dipanggil antara muka. Ini antara muka metrik dan juga kamu punya reinforcement. So, as you can see, ini pun saya dah terangkan dalam lecture 1. So, this is your primary, which is metric. This is your secondary reinforcement. This is the interface. As you can see here, this is the interface. So, this is direct bonding between primary and secondary phase. So, for the example, Al tungsten filament. So, the second one is addition of third ingredient to bond the primary and secondary phase and form an interface. Ini yang dipanggil antara fasa. Ini kamu punya primary, metrik kamu. This is your secondary, reinforcement. Dan dia tambah lagi satu ingredient. So, untuk senang kata, dia tambah 3 material. Satu kamu punya metrik, satu kamu punya reinforcement, dan satu lagi maybe it can be add as a binder. Binder ni dia dipanggil interface antara fasa. Ini boleh tengok yang dekat biru muda ni, yang tengah ni. Ini this one is antara fasa. Contohnya coating of glass fiber to achieve adhesion with thermoset resin. Maksudnya ini thermoset kamu, ini thermoset which is your primary. Glass fiber adalah kamu punya reinforcement. This one is glass fiber. Dan dia coat dulu, dia coating dulu kamu punya glass fiber, baru dia gabungkan untuk hasilkan satu komposit. So the third one is formation of an interface by solution of the primary and secondary phase at their boundary. Same like the second one, but dia gabungkan lagi banyak. So example, cemented carbide at the high centering temperature, some solubility result at the boundaries to create an interface. So interface reaction. Metric may interact with the interface layer of reinforcement result in a high temperature during fabrication operation, especially for liquid state processing. Common interface layer of titanium and alloy metric with high chemical reactivity. So, ini yang dikatakan bila kamu gunakan metrik kamu, dia akan bagi interface yang berbeza. Either strong or weak. So, untuk strong and weak, please refer back to lecture 2. Apa akan terjadi kalau interface kamu, bonding interface kamu rendah? Kalau bonding interface kamu kuat, apa yang akan terjadi? So, please refer back to previous lecture. So, how to improve the interface? How to improve the interface? Improve the response of the liquid phase process. So this one is for liquid phase process. Pre-coated graphite coating applied to the SiC fiber. Dia tak coating atas kamu punya metrik, tapi dia coating atas kamu punya fiber which is kamu punya reinforcement. Dia applied coating, dia applied graphite atas SiC fiber to improve the wettability. A slight decrease in mechanical properties. Dia akan bagi untuk case ni, dia akan kurangkan sikit dia punya mechanical properties, tapi wettability dia, workability dia akan jadi lagi mudah untuk bergabung, combine. So First yang ni dia coating atas SiC fiber. The second one dia modify the matrix composition. Dia modify matrix kamu tu sendiri. Aluminum fiber reinforced cast aluminium with the addition of lithium or magnesium into the molten aluminium. So Li2O 5Al2O3 spinel formation in fiber to promote wettability. Yang ni untuk kes ni dia modify matrix composition dalam aluminium ni, dia tambah lagi lithium ataupun magnesium. Maksudnya dia jadikan matrix kamu sebagai alloy. So if reducing the mechanical properties of MMC, the interface reaction is undesirable. Ni ya, fahamkan maksudnya? Dia bila dia kurangkan kamu punya MMC properties, so dia punya interface reaction undesirable. Maksudnya dia boleh meningkatkan lagi kamu punya antara muka, sorry. So barrier coating can be applied to the reinforcement so that the reinforcement can be combined with the matrix. If not applied, coating may be too reactive. For example, boron carbide coating allow the use of fiber B to amplify titanium. Carbon or titanium boride coating for SiC monofilament reinforced titanium alloy. So kalau kamu tak coat certain materials, dia kena coat. Kalau kamu tak coat, dia akan bagi efek yang lain. Maybe dia tak lekat dengan kuat, antara fasa dia tu tak ada, antara muka pun dia jadi lemah. Sebab tu dia coat dulu kamu punya reinforcement. So advantage of MMC, metal matrix composite are mainly used to provide advantage over monolithic metals such as steel and aluminium. This advantage include higher specific strength and modulus by reinforcing low density metals such as aluminium and titanium. Lower coefficient of thermal expansion by reinforcing with fiber with low coefficient of thermal expansion such as graphite. And the last one is to maintaining properties such as strength at high temperature. Saya ambil yang last ni ya. So kamu nak properties dia sama, tapi kalau kata kamu pakai aluminium, dia punya melting temperature dia adalah 660, tapi kamu nak go for higher application, kamu akan tambah dengan contoh yang biasa gunanya silicon carbide ataupun alumina. Sebab kita tahu silicon carbide ataupun alumina ni, dia punya melting temperature can be over to 2000, 1000 and something, over 1000. So bila dia gabungkan dalam aluminium kamu, automatically dia akan meningkatkan kamu punya properties at higher temperature. Itu sebab kamu buat composite. Kamu nak dapatkan yang sama tapi dia lagi tinggi. So advantage over polymer matrix composite, this include higher elastic properties, higher surface temperature, insensitivity to moisture, higher electric and thermal conductivities, and better wear, fatigue and flow resistance. So this drawback of MMC over PMC include higher processing temperature and higher density. So this one is advantage over polymer matrix composite. So dia akan MMC dia lebih dekat, include higher elastic properties, dia punya service temperature of course akan jadi lagi tinggi, dan dia juga dia insensitive to moisture. Maksudnya mungkin dia akan jadi tahan karat, moisture, lembapan, sebab corrosion yang as you know, the corrosion will take place if they have a moisture. So higher electric and thermal conductivity, so this one you can it can be reduce the CTE, better wear, fatigue and flow resistance. So that's all for today's class, but I have some assignment for this topic. A simple assignment. First, give definition of metal matrix composite. What are the main objectives in producing MMC? Define and give an example for each matrix ceramic. So, example for this one, this four. So, give the example. So, this assignment, I give you 1 week to complete it. Next 1 week, so which means next week, Monday, 12 o'clock. So if you're late to submit the assignment, I will reduce the mark. That's all. Thank you.